Good morning and happy Valentine's. You for what?
The day of love.
That's too bad for me. But there are some good news to it. If you forgot, just keep forgetting about it. It's gonna disturb you from getting funding next year. Or it's gonna disturb you from graduating in the next 3 years. That's what happens. I know that students have different plans. Others, they came here because they want to change the situation they have at home. Others, they came here because they have this knowing desire in their soul that I want to become this thing. I want to be called this something when I'm an adult. And then others are here because they want to explore varsity. They don't give a damn if they pass or fail as long as they explore. And of course, others are here because they feel like they are ready to start their own mini families. So they think this is a safe space. So for those of you who came here because they want to move forward, when you feel like this, maybe this means you think that you're falling behind, it's because first, you must understand that the meaning of being at Rhodes University. Rhodes University is not just any other institution, it's one of the best institutions, which means that when you are here, the work will be more. Every day you're supposed to be doing something new. And if you happen to see someone else who's doing mathematics for biologists, you must be able to solve that question. It doesn't matter where they are in the world. You getting it? So that is why you might feel like it's too much. But if you feel like you're not up for that challenge, I mean, you can always deregister. It's not a biggie. And then ask for money back. But if you feel like it's too much, but you think that you still have a chance, one thing that I know, for the first few days, especially after the holidays, always a challenge, but give it time. If you still don't understand what is going on now, you still have a chance of going through the slides. Just read them slowly as you can this weekend for this week. And then by the end of today, before 12 midnight, I'm going to upload tutorial questions. Then you will be able to practice if the knowledge you have, is it enough for you to answer those questions? That's what you'll be able to do. If you still have questions after solving these things, there's a TAT next week. And then you will ask the questions you have during the TAT session. If even after the TAT you're not satisfied, you can always consult. You getting it? I'm not supposed to say these students are annoying. Why they keep asking the same questions over and over again? Man, I get paid to do that. That's my job. On the 25th, I get paid. Where is this money coming from? It's the money you're paying for fees. You are buying education. You're getting it? The same thing if you were to buy bread at Checkers and you feel like, hey, this bread is rotten. You return it back. You don't say, I already have it. No. Even if you feel the teaching strategy that I have, you feel like you don't understand much, you can always ask someone else in the maths department, like, can you please explain this thing for me? It's okay. It's not personal. I'm not going to be like, oh, you're going to that guy. You're not coming to me. Never ask me anything again. No, it's not like that. It's all about you getting the best education. I have my PhD. I want you to have yours. You get what I mean? Imagine if you're a doctor and people ask, hey, doc, how's it, doc? Not to be worried. Are you miss? Are you Mrs.? Just remove the confusion. Become a doctor. And you have level 10, not just a medical doctor. I'm talking about the doctor, a real doctor. I'm kidding. But today I wanted us to look at inequalities. Right. And what do you know about inequalities before we can begin? Yes.
I know about greater than, less than.
There must be greater than something. That's what you're saying. Equal to something. Who have a different answer to that question? Okay, it's fine. Let me rephrase the question. Can you solve these three inequalities? Do you think you can? You can try. I'll give you 3 minutes to solve number one. Just 3 minutes. And the time starts now. That's all we have with the group today. And if you can understand this, chances are you already understand factorization. If you understand factorization, you understand all the different methods. I am not going to ask you to use this method. No, you will choose the method that you see fit. You got it? Remember, these questions usually come as a multiple choice questions. It's not like you have to factorize this method. No. There will be a multiple choice. As long as your answer is the correct one, you will see it there in the multiple choice questions. You got it? We're not here to make your life hard. If you have a good sangam and you know, today I feel like your sangam is telling you that today I feel like you just have to choose all the B's, you will make it. You can go for it. But I always prefer someone just making sure that they do the correct calculation. What if when you are consulting? You are consulting to your ancestors, they don't like this maths too. And they just like, I also want you to quit this maths. And the only way to quit this maths is when you fail it. They give you all the wrong answers. At least try and do some calculations so that you don't get disappointed. Come on, guys. This is not that hard at all. X cubed, 1x, 2x, and 3. Come on, guys. Only 3 x's here. What if I had to put x to the power 10 and say go? And remember, in the exam, you don't have time to think, you have time to write. When we're allocating time for the exam, is for you to write. So if you don't practice, you're not going to make it, not because you don't know, because you did not practice. So you must practice. Know everything we're doing here by heart. The 3 minutes is up, guys. It's up. What is the correct answer? Okay, continue. Let's continue and see if you're going to get the correct answers here. Okay. Now let's start with this. Right. What is the meaning of this symbol? It is less than. What is the meaning of this symbol? What is the meaning of this symbol? What is the meaning of this symbol? Okay, thank you. Which means we're happy so far with this. Now, how do you solve inequalities in general? What is the first step that you have to make sure that it is satisfied? You take everything to one side, bring everything to one side. If you like the right hand side, bring everything to the right hand side. Do you get it? But in this case here, everything is already on the left hand side. That's the first rule. Bring everything to the left hand side. Right. The second step is this whole thing, you change the inequality to equality. You getting it? Plus a 6, and then you say equal to a 0. You getting it? And then the third step is you want to solve for this equation. What are the values of x that make this equation equal to 0? That's the first, that's one of the things that you have to do. You're getting it in this step. And then the second one, which is also important, what are the x values that are making that equation undefined? You're getting it? In other words, this step is all about finding the critical values. You're getting it? Is there any value of x that make that equation undefined? Yes or no? Guys, please, let's forget about Valentine's for now. Let's focus on this. Is there any value of x that is making this equation undefined? No, this is a polynomial, it's a strict polynomial. Whatever real number that you plug in there, you will get a value there. Now, is there a value of x that can make this equation equal to a 0? How do you find it? You find the factors of the last term. What are the factors of the last term? Is plus and minus 1. Let's test them before we move on. You getting it? If I take a plus 1 and I plug it there, what will I get? Get a 0. Wow. Which means x is equal to 1 is a solution. Is that what they're saying? Or x is equal to 1 is one of the zeros of that equation. You getting it? It's one of the zeros. Solution and the zeros, one and the same thing. That's why I keep interchanging this, so that if it happens that I get to live here and someone else comes and they set the exam, you know when they're saying find the zeros of this. You getting it? Now, once you have this, which means that x minus 1 is one of the factors when you're factorizing this equation. You getting it? So now you're going to have x minus 1, and then this side, you are trying to find out what is here. You getting it? Now, we said that we have two methods that you can use. One is synthetic division or the long division. The other is factorization by inspection. Which one do you want? Inspection or long division? You don't like synthetic division? Okay, fine. Let's just take a quick synthetic division because we have never done it, and then you can go back and try the inspection. You getting it? You're gonna get the same answer, guys. Come on. So the synthetic division is simple. You just draw this nice half of a rectangle, right? What is the value of x that is making that equation equal to 0? You place the 1 outside, right? And then after that, what you do is you just say, okay, let's look for the coefficient in front of the x's there. So you have in front of x cubed, what do you have? In front of x squared, what do you have? -2. In front of x, what do you have?
Negative 5. In front of x to the power 0, what do you have? You have a 6 there. Then you are done. The next thing that you have to do, you drop that 1 down there. You getting it? What is 1 times 1? So you place your 1 there, which is positive. Minus 2 plus 1, what do you get? Negative 1. Okay. Now, negative 1 times 1, what do you get? Negative 1. Negative 5 plus negative 1, what do you have? Negative 6. Negative 6 times 1, which is outside, what do you have? Negative 6. 6 plus 6, you have a 0, which means that this actually was one of the factors. Right. Now, what does that thing actually mean? It means that if you were to factorize that equation that we have out there, the part that should be here, where's this? The part that should be here should be 1x squared, 1x squared here. Let me put this. 1x squared minus x minus 6 and a 0. 0 is still nothing. You getting it? Now, that equation can be factorized like this. The question is, can you factorize this part? You already have x minus 1, and you want 2 this side, and you want this to be equal to a 0. How do you factorize a quadratic equation or a quadratic expression? Look at the last term if you are using either the splitting method or the long division. What are the factors of minus 6? You have a plus and a minus 1. Okay. If I'm plugging plus 1 there, will I get a 0? In x squared minus x minus 6, will I get a 0? No. So this is not one of the factors. If I'm plugging a minus 1 there, what will I get? Will I get a 0 or not? You're not going to get a 0. This is not one of the factors. And then you go to plus and minus a 2. If I take a positive 2 and I say positive 2 squared, what will I get? 4 minus 2 minus 6. Is that a 0? So positive 2 is not the one of the factors. You're getting it? And then if I'm plugging minus 2, what is minus 2 squared? Minus 2. 6 minus 6. So minus 2 is one of the factors. You're getting it? So this side you're going to have an x, this side you're going to have an x. And then this side, one of the factors was minus 2. But we said that whenever you have a minus, you change the sign. So this is supposed to be a plus. You're getting it? Now, what is x squared divided by x? You're going to have this x here. What is minus 6 divided by positive 2? Negative 3. This is how you factorize this. You see how easy this is? It's not that hard, guys. Easy. It's fine. You can use any method, guys. I'm introducing this method here because I noticed some of the students, they don't like this inspection thing. They like synthetic division. You're getting it? Yes. Now that you have this, what are the values of x that make this equal to 0? X is equal to? X is equal to? X is equal to? 3. So these are the zeros of that particular equation. You're getting it? Now the next thing is you draw a number line. You getting it? Yes. Once you draw your number line, how many zeros do you have there? So you're going to have 1, 2, 3. And then which of these numbers is bigger than is the biggest of them all? Is 3. The next one is 1 bigger than minus 2. Oh, so you have a 1 and then you have a minus 2 here. Are you happy so far? The next thing that you do, you draw little holes on top of all of the tree. Little holes, which means there is something that will get inside. You getting it? Now, if it happens, focus guys, focus here. If you have these holes here, what do you do? Listen, you go back and check the original inequality. If the inequality is less or is just greater, you are not going to shade anything. You getting it? If the inequality is greater than or equal to or less than or equal to, that's when you shade, right? Now, is this greater than or equal to? No. Is this less than or equal to? We are not shading anything. You getting it? Okay. Now that you have that, you are fine. The next thing that you do, you pick a number that will work for you, that is less than -2. And then you plug it in the original inequality. You getting it? Okay. Let's move here. If I were to plug here -3, what will I get? Am I going to get a positive or negative? I'm going to get a negative, okay. If I were to plug here -3, what will I get? Will I get a positive or negative? I get another negative. If I were to plug in here a -3, what will I get? A negative or a positive? A negative. Negative times negative times negative. So here you have a negative. You getting it? Now you pick a number that is somewhere between -2 and 1. What is that number? 0. Thank you. If I plug in 0 here, what will I get? A negative? Yes, I will get a negative somewhere. If I were to plug in 0 here, what will I get? Positive or negative? I will get a positive. If I were to plug in 0 here, what will I get? A positive or negative? I'll get a negative. Negative times positive. Negative times negative. So whatever you will get here will be a positive. You getting it? Yes. And then we pick a number between 1 and 3. What is that number? If I plug in a 2 here, will I get a positive or negative? A positive. If I plug in 2 here, will I get a positive or negative? A positive. If I plug in 2 here, will I get a positive or negative? Positive times positive times negative. You have a negative here. And if I were to pick a number that is greater than 3, what will that number be? If I plug in a 4 here, what will I get? A positive or negative? So you get a positive. If I plug in here a 4, what will I get? A positive or negative? A positive. If I plug in 4 here, will I get a positive or negative? Positive. Positive times positive times positive. So here you are having a positive. You're getting it? Now the question is, if you go back, what's this now? Yeah. If we look back to our inequality here, we had a less than, right? And now that you have a less than, which means we are looking for the number that is less than a 0. You're getting it? A number that is less than 0, is it positive or is it negative? Okay, which means we are looking for the region that is negative, a region that is negative. You're getting it? Now, how do you write the answer that this is what I'm looking for? This is what I'm looking for. I don't know what this thing is doing now. What is basically happening here is that we had this this less than there, so which means that we are looking for a number that is less than a 0. You're getting it? Now we said this region is the region that we are looking for, that have a number that is less than 0, and this region is what we are looking for. Now here's the thing: How do you say that this number is less than a minus 2? It's simple, very simple. We're looking for the x values here. We're looking for real numbers there. There are two ways to represent this. One is using interval notation and the other is using the brackets. You getting it? Now, if let's say you don't know any of that thing, you know that as long as the number is less than 2, you are fine. So you are looking for x that is less than a minus 2. You getting it? Or as long as this x is less than a 3, you are fine. And of course, as long as this s is greater than a 1, you are fine. This is the answer we're looking for. You getting it? If you want to write this in terms of brackets, you can see that when you're moving from negative to 2, you are going all the way to negative infinity. You're getting it? So you can say, okay, this part is the same as negative infinity to minus a 2. You're getting it? But because 2 is not shaded, which means it's not included, we use open brackets. These brackets, like these curved brackets, we say they are open brackets. You're getting it? And then because we will never touch negative infinity, we never touch it, which means we'll never include it. So we always use open brackets also for negative infinity or positive infinity. Do you get it? Okay, I will. Okay. Yes. Square. Or is the union. You getting it? And then this one is not included, open brackets. 3 is it? Is 3 included? So this is okay? No, because we wanted to use open brackets only if 3 is not included and closed brackets only if 3 is included. Are you getting it up to this far? So you have this. No. Okay, let me start afresh. I said that. Okay, do you understand up to this far? You don't understand how to write this part. Okay, do you understand up to this part? This is the part that you don't understand. So you would like us to take another example? Yes or no? Yes. Okay, let me just finish this part and then we are done. Remember that if you write this, you will get full marks. Or you write this, you will get full marks. You getting it? The third one is, this x that you are looking for is a real number, right? So you can always say, okay, this x that you are looking for is the element of real numbers such that, take note, such that, what's this? Yeah, x is an element of real numbers such that minus 2 is always greater than x, right? Or x is less than 3, less than or equal to 1. Can you see this? Yes. So you can either write it like this or that or that. It's still fine. Are you happy up to this one? Okay. Should we take a different example? Or this example, but a little bit complicated? Easy. Okay, it's fine. Let me check here what we have. How about number 2? How about number 3? Guys, number 1, number 2, or number 3? Those are saying number 1. Number 2, guys, you don't want it. You want number 2? Yes. Okay, listen, guys, listen. There is also another example here in these notes. We can go straight to it. This is what you said, guys. There's nothing new here. This is also another example that we can look at. Where's this? How about this one? How about this one? You want this one? Okay, look, guys. Part of my class needs this number, this question. I'm gonna do this question and also number 3. Is that fine? Okay, happy. Now, what is the first step of this? Just copy this because I'm gonna move to a different paper. But this is not that hard. You don't have to worry much. It's not that hard at all. Yeah, it's just one of the basics. But we have to spice these basics up a little bit. Okay. The question, what is the question? Sorry, ma'am. Yes, you have a question? What is the question? To draw it. Okay, this is the thing. Chances are very high that you will get something that you cannot graph at the moment. So the number line is okay. But when it comes to quadratic, if you can graph it, it's fine. But when you are graphing a quadratic, if let's say A is positive, it's going like this, right? If A is positive, is the graph going this way or that way if A is positive? You smile, come on guys, if A is positive, the relationship is positive, it's going in a positive direction. Come on, you smile. So if it's going like this and you have less than, there you must have a hole. There you must have a hole. If there is no hole, you are wrong. That is why I was using the number line, but even if you graph it, it's supposed to have a hole in a hole. You getting it? Yes, that's what is important. Yes? You are allowed to, and you'll get full marks. Yes, at the back. Yeah, if let's say I were to graph the current problem that we have, the problem we have is a cubic. We haven't touched the graphing of cubic functions. So if I have to go there, I still have to teach you some few things. So I cannot graph it at the moment. I can graph it, but I'm not sure about you. So we still have to graph it later. We'll graph later. So for now, just use the number line. Happy? Yes, ma'am. The derivatives. How can you graph it? Is that what I'm saying? If you don't have a calculator. Let me tell you this. In this course, we'll do shifting, scaling of functions, and shifting left or right or up and down. We're going to do that. Stretching the function, we're going to do that. Stretching the function, we're going to do that. Shifting, we're going to do that. So as long as you know the graph of y is equal to x squared, then if you have anything that is quadratic, you're going to use the completing square method to have something that you can use to shift x squared. You getting it? Yes. So you don't need a calculator. There's no excuse for calculator here. You've never seen me carrying a calculator. So what is the question, guys? Time is flying. We have 3x cubed minus 2x squared and minus 12x plus 8 less than or equal to? Okay, fine. Less than 0. What is the first step? If there is anything on the left, bring it to the right, or if there is anything on the right, you want to use the left, bring everything on the right to the left. You getting it? And then you know that when you are taking anything from the left to the right, it changes its sign. You getting it? If you have to multiply the whole inequality to remove something, if the number you're multiplying with is positive, the inequality does not change. You getting it? If the number you are multiplying with is negative, you change the direction of the inequality. If it was going this way, it's going to go this way. You getting it? If you are dividing with the negative number, the inequality changes. You getting it? If you are dividing with a positive number, the inequality changes. You getting it? Does it change if it's positive? Yeah, it doesn't change. Now that we have this whole thing, what is the first step? What are the factors of 8? So negative and positive 1. If I plug in 1 in the first one, what will I get? I will get 3. 3 minus 2. Minus 12. Minus plus 8. Is it a 0? So plus 1 is not working. If I plug in minus 1, I will have minus 1 cube is minus 1. Minus 1 times 3 is minus 3. Minus 3 minus 2. Minus 3 minus 2. Minus 5 plus 12. Plus 8, is it 0? So this one is bad. Plus or minus 2. If I plug in a 2 there, 2 cube, I will tell you is 8. 8 times 3, what is 8 times 3? 24. 24 minus 2 times 2, which is 4. What you are left with? Minus 12 times 2 plus 8. Are you getting a 0? If you plug in a minus there, what are you getting? Positive or negative? Or 0? So x is equal to 2. X is equal to minus 2 is actually one of the factors. Is that what they're saying? Okay. I am saying to you, this thing, if you take this minus 2 to the other side, you will end up having x plus 2. You getting it? That is one of the factors. I will help you after this one. What is the factor that when you are plugging here, you get a 0? It's negative 2. Positive 2. If you have a positive 2, hey guys, you are making me drunk. If you have a positive 2, what you do, come on guys, listen, if you have a factor is positive 2, when you are creating one of the factors, you just change the sign. You getting it? If 2 was positive, here, what will it be? So you're going to have negative 2. So the factorization is going to be x minus 2. You getting it? And then you multiply that. And then you're supposed to have a 0 on the other side. You getting it? Because we want to first solve this equation equal to 0 or undefined. The first thing that you do, we said we change this to equality. You getting it? Yes. Now that you have this, what will be here? You either use factorization by inspection, right? Or synthetic division. I asked you which one do you like? Synthetic division. How does it work? We said, what is the factor that is making that equation equal to 0? We said it is 2. You write 2 outside, and then you write something of this kind. And then you go back there, you take the coefficients or the numbers that are in this equation, which is 3 minus 2 minus 12 and 8. Are you getting it now? Now that you have that, what do we do? And how will we know if this 2 that you are claiming is a factor or not? If here we are not getting a 0, which means this 2 that we chose is not a factor. But if we are getting something that is not 0, it's not a factor. But if we are getting a 0, which means it is a factor. You getting it? Yes. Now let's go back and see. It might be a potential date. Take the 4. But here is the thing. Now that you have this, guys, come on, listen. You drop the 3, you getting it? 3 times 2, you have your 6 there. Minus 2 plus 6, you have a 4 there. 2 times 4, you place your 8 there. Minus 12 plus 8, negative 4. Negative 4 times 2, negative 8. 8 plus minus 8, which means that we will have x minus 2, and this side you're going to have 3x squared plus 4x minus a 4. That's what I was saying. Then you have to factorize this part. Are you getting it? That's what I was saying. I think the class is... Are we done, right? We still have 3 minutes. Look, guys, how do we factorize this part? We look for the factors here of 4. What are the factors of 4 such that when I'm plugging it here, I get a 0? Factors of 4. If I plug in a 1 there, I will get a 3 plus 4 minus 4, which is not 0. You getting it? If I plug in minus 1, I will get a 3 minus 4, which is minus 1. Minus 1 minus is not a 0, which means let's try 2. If I'm plugging a 2 there, what is 2 squared? 4 times 3, 12 plus 8, minus 4. Are we getting a 0? If I'm plugging a minus 2 there, what will I get? A 0. Yes. So you're going to have an x minus 2, and then this side you're going to have x. What is it, minus 2 or plus 2? Plus 2, because you change the sign. And then after that you say 3x squared divided by x. It's going to be 3x. Minus 4 divided by 2, minus 2. Are you getting it? And then you have a 0 there. Now that you have that, you draw a number line, right? How many zeros do you have there? What is the first one? Negative 2. What is the next one? 2 over 3. What is the last one? 2. And then what you do, you have some holes there. Remember that if there is a hole, there must be something getting inside. You getting it? So if the inequality here was less than or equal to, we're going to shade. If that was not the case, we don't shade. You getting it? Now, because it's not the case, we don't shade anything, but we pick the numbers 1 that is here, 1 that is here, and 1 that is there, and 1 that is there. And then we check which region is positive and which region is negative. Are you getting it after this one? Is that hard? Now, what do you do when you have a denominator? Like this, this equation here. Let me look into it. Just 1 minute, guys. You don't have to panic. You don't have to panic at all. Let's say you have number 3. How do you deal with that? You factorize first. You factorize first and then? Listen, guys. We are not solving here. We are solving inequalities. You are not cancelling anything. You are not cross-multiplying anything. What you do, I said the first thing, look for the values of x that make the equation equal to 0. In other words, you look for the values that make the numerator equal to 0. You deal with the numerator alone. Then the next step is, you look for the values of x that make the equation undefined. In other words, you deal with the denominator alone. You getting it? So you will get critical values for the numerator, critical values for the denominator. Then the critical values that you had for the denominator, you don't shade them. Whether it's less than or equal to or greater than or equal to, you don't shade them. You will only shade those for the numerator. You getting it? With inequalities, you're not cross-multiplying anything, guys. You getting it? But the complete solution for this is on the notes. I will upload it. Thank you.